At this point in the course, we are capable of building basic React apps. We learned a lot about some of the most important features that are baked into React, but there's one thing that's really missing or that we haven't had a closer look at until now, and that is how React actually works behind the scenes. Now, I know that to some students, this is not interesting. You might be one of them. And generally, that's of course fine. You are using a library like React so that you don't have to do all the heavy lifting on your own. However, it really helps to understand how something works that you're using to ensure that you are using it correctly. And whilst I, of course, do teach you common practices and best practices throughout this course, it nonetheless is important for you to know the tool so that you are able to make the right decisions in the apps you're going to build. So even if that's not super interesting to you, I would strongly recommend that you don't skip this module and at least go through the videos at a higher speed if you're really not interested. We'll also dive in some new features which are related to the behind the scenes work, so I would recommend that you at least watch those lectures, though they will of course make more sense if you watched the entire module. So what's in this module then? We'll have a look at how React works behind the scenes. That does not mean that we're going to dive into the source code. It means that I will show you how React works with your components, how it updates those components, how state is related to all of that. We'll understand that React uses something which is called the virtual DOM, and we'll understand how that works and how it affects updates made to the real DOM, which is in the end what drives your website in the browser. And we'll take a closer look at state management, how React does that, and how state updates are managed by React. A lot of important concepts, so let's dive right in. So, how does React work? Let's not forget that React is a JavaScript library for building user interfaces. That's what I taught you at the very beginning of this course, and of course it hasn't changed. We also learned and we saw that React is all about components. We use components to build those user interfaces, and React embraces this component concept. It uses components to effectively compose user interfaces, and it uses components to effectively update user interfaces. There's one important note. We also saw this React DOM thing. And in the end, React DOM is your interface to the web. React itself, React.js, does not know the web. It does know nothing about the browser in the end. React knows how to work with components, but it doesn't care whether those components contain HTML elements or if they contain totally fictional elements. That does not matter to React. It's React DOM to which that matters in the end, and which ultimately needs to bring real HTML elements to the screen. But React is just a library that manages components, that manages state, and that manages different component states, and that finds out how components might need to change and which differences you might have from a previous state of a component compared to the current state. And React hands all that information regarding what changed and what should be visible on the screen, no matter what screen that is, off to the interface it's working with. For example, it hands it off to React DOM, because React DOM is then responsible for working with the real DOM, which is part of the browser, and therefore React DOM is responsible for bringing something onto the screen which the user is then able to see. React only cares about components. It cares about props, which is basically data you pass to components to make components configurable and to enable parent-child component communication. React cares about state, which is internal data inside of a component. And React cares about context, which is component-wide data. Now, of course, React has a couple of other features built in as well, but these are the core features. And whenever props, state, or context changes, components that use these concepts are updated by React, and React checks whether this component now wants to draw something new onto the screen, And if that should be the case, React will let React DOM know about that so that React DOM is able to bring that new screen, that new component, that new output to the screen. So therefore, if we have a closer look at that components real DOM communication here, the question of course is, how exactly does this work? As I mentioned, React is concerned about components. And what React in the end does is it uses a concept called the virtual DOM. It determines how the component tree, which your app is building in the end, and every component itself, of course, has a subtree, the JSX code returned by that component. It determines how that component tree currently looks like and what it should look like, for example, after a state update. And that information is then handed off to React DOM, which now knows about the differences and which then knows how it should manipulate the real DOM to match that virtual DOM, that virtual snapshot React derived for your component trees. And related to that, there's one important thing to note. Throughout this course, I often said that React would rerun a component function, that it would re-evaluate a component. And indeed, as I mentioned before, whenever state, props, or context of a component changes, that component function is re-executed. That component is re-evaluated by React. But it is worth noting that re-evaluating a component is not the same as re-rendering the DOM. So just because a component function is re-executed by React does not mean that the respective part of the actual real DOM is re-rendered or re-evaluated. Instead, we have to differentiate between our component part, our React part, and the real DOM. Our components, as I just said, are re-evaluated whenever props, state, or context changes. So React then executes that component function again. Now, the real DOM, on the other hand, is only updated in the places where it needs to be changed based on that difference React derived between the previous state of a component and its tree and the current state after the state, prop, or context change. So the real DOM is not changed all the time. It's changed rarely and only when needed. And that's important for performance, because making a virtual comparison between the previous state and the current state, that's fairly cheap and easy to do. That happens only in memory. Reaching out to the real DOM that's rendered in the browser is pretty expensive from a performance perspective, because working with the real DOM just turns out to be a performance-intensive task. Of course, not a tiny change in one place, but if you do that tiny change in a lot of places all the time, then your page might become slow because you're working with the real DOM too much. And that's why React has this structure of doing virtual comparisons with that virtual DOM and then only passing the changes between your last snapshot and the current snapshot to the real DOM. That's how React works here. It does this virtual DOM diffing, finding out the difference between two snapshots. And to see a real example, it could look like this. Let's say of a given component, our previous evaluation result, so when the component function ran the last time, is this. And now some state changes, and all of a sudden we want to show a new paragraph. So that's our current evaluation result. In this case, React would determine that the difference between both snapshots is this paragraph, and it would report this change to React DOM so that React DOM can update the real DOM and insert this paragraph. React DOM would not re-render the entire DOM. It would not touch this existing h1 or div element. It would only insert the paragraph after the h1 element inside of the div. That's how React works behind the scenes in a nutshell. Now let's see this in action with some real code, and let's play around with that a bit so that we get a feeling for this and so that we can also find out how this all behaves and possibly changes for props and state changes, for context, and for other components being involved, because it is really crucial that you understand this. Attached, you find this very simple application, which in the end currently just has this app component with a div and a h1 tag. So essentially what you just saw on the slide here. And now let's replicate that behavior I showed you on the slide. Let's say for some reason, eventually a paragraph should be added here. Now, how can we eventually add this and not add it right from the start? Well, with a state change, for example. We could have some state which changes such that initially no paragraph is rendered, but then at some point, because a button was clicked or a timer expired or anything else happened, the paragraph is displayed. Now I will work with a button here, and therefore first of all I will import use state, of course, because we need some state, because as I mentioned, React will only rerun this function and re-evaluate what's on the screen if state, props, or context changes. Now, since this is our root component, props and context is a bit harder, and in the end it's also worth noting that of course it all comes down to state changes ultimately. Even context internally will use some state that might change the value which is then distributed through context. And if we think about props being passed from a parent to a child, how could the value passed through props change? Well, ultimately, only if state in a parent changed. It all comes down to state changes in the end if you think about it. So therefore here we're going to work with some state, and I'll name my state here show paragraph and set show paragraph. And initially that is false. My initial state here is false. And then here we use show paragraph as you learned it in the conditional module, in the conditionals module. This is how we can show a element conditionally. Now, if I save this, of course we will not see the paragraph because our state is false, and currently we have no way of changing that state. Now, in the starting project, you find a button component, just so that we have a nicely styled button. So I will add this button component here, import button from /components UI button. Show paragraph is the label we could have on it. And then here we can add the onClick prop on the button and add a function here, toggle paragraph handler, for example. And this function should trigger when the button is clicked. And it should actually toggle the paragraph, let's say. So I'll rename my caption here to toggle paragraph. And in there, I will then set show paragraph, and I will set the state to what show paragraph currently is not, so that we basically inverse it. The short form would be this syntax, where we set the value for show paragraph to the opposite of the old value. But since we depend on the previous state snapshot, I mentioned that we want to use the function form for the state update here. I will come back to why we do that later in this module again, by the way. And therefore, let's use the function form, previous show paragraph, and we return the opposite of previous show paragraph, therefore. And this is the cleaner way of changing our state. And now we bind the toggle paragraph handler to the button. So with that, we have the logic to conditionally show the paragraph. Now to center this, I'll quickly go into my styles here and add text align center here in the app selector. Side note, I'm not using CSS modules here, I'm just using regular CSS imports. Okay, with that, let's click toggle paragraph. And you see the paragraph is here, and it's gone, and it's here, and so on. Now that's interesting to know. But let's now analyze what's happening. First of all, I always mentioned that state changes, prop changes, and context changes would result in this component function being executed again. If that's the case, we should be able to add a console log here and say app running and see this whenever we click the button in the end. Well, let's see whether that's the case. I'll save that. Here's my console, and you see initially app running. That is because the page reloaded and that brought this app component to the screen for the first time. So of course this was executed by React. And for that first render cycle, React then found out that it wants a div, a h1 element, and a button, no paragraph, because initially that's not shown. And it checks that to the last output it saved. And since this rendered the component for the first time, there essentially is no previous output, there is no previous snapshot, and therefore this difference comparison in the end resulted in a div, a h1 tag, and a button to be rendered. And that information was handed off to the React DOM package, which therefore rendered that to the screen. Now if I click toggle paragraph, we see app running again. So that proves my point that for every state change, the entire component in which the state changed is re-executed, is re-evaluated. Now, how is the real DOM affected though? For that, let's go to the Elements tab in the DevTools, and let's expand our div here, the app div. Now, if I reload, we see we just have the H1 and the button element here initially. And now, the good thing about this Elements tab is that things that are changed in the DOM will be flashed. They will be highlighted so that we can see where the real DOM was re-rendered or updated. Now therefore, watch this part on the right here as I click the toggle paragraph button. You see, the only thing that flashed was this paragraph. The H1 and the button element did not flash, neither did anything else. It was just a paragraph. And if I remove it, it's just a div, because from there the paragraph was removed. But the H1 and the button elements were not flashed because they were not re-rendered. And that's what I meant. Only the difference between those virtual snapshots was considered for the updates made to the real DOM. And that is really, really crucial to understand. Now let's see how that might change if we work with more components. For that, in the components folder, I'll add a new subfolder. I'll name it demo. And in there, I'll add a new file, and that's my demo output.js file, where I import React from React. And then here I have the demo output, where I get props. And I export this as a default, of course, so that's a standard component. At least it is as soon as we return JSX. And now I'll take my paragraph here, this is new, remove this line here from the app component, and add it instead here as the return value. To be precise, I'll do something slightly different now. I will not conditionally render my own component or not, because it should be obvious that this will behave like rendering the built-in paragraph component or not. Instead of demo output, I'll change the HTML structure a tiny bit. It'll not just be this paragraph, like this. Instead, I will render this text in the paragraph conditionally. And I will render it conditionally based on some data I get through props. So that I can check if props show, for example. So if the show prop is truthy, let's say we expect a Boolean here, so if it is true. And if that is the case, then I want to render this is new, otherwise I will render an empty string. So the paragraph element is always rendered, just the text changes now, based on the show prop. So now back in app component, I therefore want to include my demo output here. So make sure you import demo output, of course. And there I want to set the show prop, because we use that show prop in demo output. And the value we pass here should of course be show paragraph, because that is a Boolean. It is false initially, and it's changed to true if we click the button, and then back to false, and so on. So now this component here is always rendered, and in the component the paragraph is always rendered, but the text that's shown, that will change based on the show prop. So now if I save that, let's go back. First of all, if I click this, you see we got basically the same behavior as before. There is no great difference. Now, if we expand our DOM here a little bit, we see, of course, that the paragraph is always there. But again, if we click the button, we see that the paragraph flashes when I click it, and it flashes again if I click it again. The reason for the paragraph flashing is that we now only work with that element, and we add or remove the text. And this is treated as a change for the entire element, which is why the paragraph flashes and not just the text. Because the text is basically like a prop to the paragraph, you could say. It's its content. But again, it's just a paragraph. It's not the H1 or the button element. So the fact that we're using a custom element, a custom component, does not change this. And of course it shouldn't. The updating mechanism should always work by comparing differences. It is of course interesting to see that we are changing state in the app component, and yet only the paragraph, which is part of another component, flashes. So this of course proves that the React updating and diffing mechanism works and finds out changes correctly. Now, one other thing is also interesting though. If we go to the console and I reload here, you see app running, and you see that of course runs whenever I click this button. Now keep in mind, the actual change happens in demo output. But of course the app component runs again as well, because that's where we manage the state. And I mentioned the component where you manage state or where you have props or context and that state, props, or context changes, that component will be re-evaluated and re-executed. And we are managing the state in app. So just because the change visually only affects this paragraph in another component does not mean that the app component is not re-evaluated. Of course it is, because there we manage our state. And that's, by the way, also what I meant earlier with props and context, in the end always coming down to state changes. The props we got in demo output are of course responsible for why demo output is re-rendered. But ultimately, of course, the value we get here on the show prop is the value we manage in the show paragraph state. Ultimately, it all comes down to state and state changes in React. Now, it of course should be obvious that if I now add a console log here in demo output, that we'll see this being printed for every button click as well. We see it initially because that component is rendered initially. And then if I click toggle paragraph, well, we again see demo output running for every click. And again, that makes a lot of sense because the props changed with every click. So thus far, this hopefully all is pretty clear and pretty straightforward. Now I'll show you something that might be confusing. Keep in mind that demo output running is printed for every click. And again, that makes sense because we do change the state and therefore the props here with every click. But now let me tweak this. In app.js, I will now hard code the value I pass to show, and I will set this to false. This means that we'll never show the output because it's now detached from the show paragraph state. Indeed, I'm not using the show paragraph state at the moment. I'm still changing it, but I'm not using the state value. Now, what would you expect as a result? Let's see. If the app reloads, we see app running and demo output running. Makes sense, the app just loaded, both was rendered. But something interesting happens when I click toggle paragraph. If I do that, you see app running, okay, we changed the state there, but you also see demo output running. And that's interesting. The props didn't change, right? We have the show prop, and the value I pass in there is still false. It never changes, it's always false. So why was demo output re-executed? Well, let's take it step by step. The app function is re-executed because state changed there. Now, what is part of that app function? Of course, this return statement, and there we return some JSX code. Now, all those JSX elements here, in the end, are like function calls to the respective component functions. So we call the function for the demo output component, we call the function for the button component. That's why those child components are also re-executed and re-evaluated just because the parent component changed, because they are part of the parent component's function body. And if the parent component function runs again, of course the child component functions also run again. So in the end, the prop value doesn't even matter here for this component to be executed again. It's just the fact that the parent changed. Changes in props might lead to actual changes on the real DOM, but for the function to be re-evaluated, it's enough that the parent component was re-evaluated. Of course, the fact that demo output runs again does not mean that the real DOM is touched. We can verify this with elements. There, you'll see that nothing flashes. I can hammer that button and nothing changes there. Because React just re-evaluates the components, and as you learned, re-evaluating a component and rerunning its component function is not the same as re-rendering the real DOM or manipulating the real DOM. But it is really important to understand that if a component is re-executed, all its child components will also be re-executed and re-evaluated. So therefore, of course, not just the demo output component is re-evaluated, the button is as well. If I console log button running here, you will see that if I go to console and reload, we see all 3 outputs initially. And if I click this toggle paragraph button, we also see all 3. So the button component is also re-evaluated as well. This, of course, brings up one question though. Here we have a very simple app, just one root component with 2 child components, which then each don't have any more child components. If they would have child components, though, those child components would also be re-evaluated. Of course, and I can show this to you. If I add a myParagraph.js file here, where I essentially copy demo output, but I then simplify this, and here I have my paragraph also as a component name. And then in there, I just output a paragraph tag with props children in between. I can use my paragraph instead of the built-in paragraph, and I'm really just doing this for demo purposes here to show you how React updating works, not because this would be such a useful component. It isn't. But now with that, if I add my paragraph, which replaces the built-in paragraph, just to then reuse it, if I add this, you of course will see in the console that my paragraph running also is re-executed for every button click. So this continues down the component tree, and this brings up one important question. Isn't this bad? Because if all those component functions are re-executed, that's a lot of ongoing function executions and virtual comparisons that certainly cost some performance, right? So isn't this bad if there actually is no reason for that? Because we know, for example, that we never need to re-evaluate demo output because it can't change. The only prop which it has is hard-coded. If it had no props at all, we also would know the output in there will never change because of the state that's managed in app component. So re-executing demo output and all its children is a total waste. Well, this certainly costs some performance. Of course, we got ongoing function executions, we got a virtual comparison. It's needless to say that React is highly optimized for those executions and comparisons. So in a lot of apps, and especially in simple apps like this one, this will absolutely not matter. Nonetheless, in bigger apps you might want to optimize that, and therefore you as a developer can tell React that it should only re-execute this demo output component under certain circumstances. And those circumstances would be that the props which this component received changed, for example. So that if I bring back show false here, React actually checks if the show value changed, and only if that's the case, it will re-execute demo output. That might be closer to the behavior we want. How can we tell React that it should behave like this? Well, we have to go to the component for which we want to opt into that did the prop change check, and we simply wrap our component, for example here in the export line, with React memo. This is for functional components. For class-based components, this does not work, but I'll take a closer look at class-based components and how to optimize those in the class-based component section later down in the course. Since we can basically work with only functional components, class-based components are not the focus here. So React Memo allows us to optimize functional components. Now, what does Memo do? It tells React that for this component, which it gets as an argument, React should look at the props this component gets and check the new value for all those props and compare it to the previous value those props got. And only if the value of a prop changed, the component should be re-executed and re-evaluated. And if the parent component changed, but the prop values for that component here did not change, component execution will be skipped. If we wrap this and we save that, we can see the result of that by going back. Initially, of course, demo output is executed because the app was just rendered for the first time. But now if I clear the console, if I click this button, you see only app and button running is being printed. The demo output running is not being printed. And therefore, my paragraph running is also not being printed because my paragraph is a child of demo output. And if demo output is not re-executed, of course, its child is also not re-executed. So this is now an optimization in place here that avoids this unnecessary re-rendering. Now, that might bring up a new question though. Why aren't we using that on all components if it allows us to optimize them? Because this optimization comes at a cost. The memo method here tells React that whenever the app component changed, it should go to this component here and compare the new prop values to the previous prop values. So therefore, React needs to do two things. It needs to store the previous prop values and it needs to make that comparison. And that, of course, also has its own performance cost. And it therefore greatly depends on the component you're applying this to, whether it's worth it or not. Because you're trading the performance cost of re-evaluating the component for the performance cost of comparing props. And it's impossible to say which cost is higher because it depends on the number of props you have and on the complexity of your component and the number of child components your component has. Of course, React Memo can be a great tool if you have a huge component tree with a lot of child components, and on a high level in the component tree, you can avoid unnecessary re-render cycles for the entire branch of the component tree. Like in this case, by avoiding the re-evaluation of demo output, we're also automatically avoiding the re-evaluation of my paragraph, even though we're not using React Demo in there, just because we cut off this entire branch, so this entire branch of the component tree. That is something where React Memo can definitely be worth it. If you, on the other hand, have a component where you know it's going to change or its props values are going to change with pretty much every re-evaluation of the parent component anyways, then React Memo doesn't make a lot of sense. Because if the result is that the component should re-render anyways, well, then you can also save that extra comparison of the prop values. That's then just some overhead cost, which is not worth it. And of course, ultimately, as always, it depends on your app size. For small apps, for small component trees, and so on, for all of that, it might simply not worth it to add this. But for larger apps, where you can cut off entire branches of unnecessary re-evaluations, it might very well be worth it. You just don't want to wrap every component with React Memo. Instead, you want to pick some key parts in your component tree, which allows you to cut off an entire branch of child components. That's way more effective than doing this on every child component. So now that we learned about React Memo, let's also apply it to the button. We can argue whether that's good or not, because the button is a trivial component, so doing that prop checking might not be worth it. On the other hand, we as a developer know that this button realistically doesn't really change. So re-evaluating the button all the time shouldn't be worth it. There's nothing on it that changes, right? We have the same text, we have the same function, so why don't we wrap it? For that, let's go to button and use React Memo down here and wrap our button component with it. Now you will see something interesting if you do that. If you save that and reload the app, of course initially we see button running, but now if I click toggle paragraph, we again see button running. Why is that happening? That makes no sense, right? Well, we see button running again and again because actually its prop values did change. That's strange, right? If we have a look at that, it only gets one prop on click, or actually two props, the children here, but both prop values never change. We always have the same text and we always have the same function, right? Well, this is one of the most common gotchas with React. Keep in mind that this app component is just a function in the end. And it re-executes like a normal JavaScript function because it is a normal JavaScript function if your state changes. The only magic thing here is that the function is going to be called by React and not by you. But then it still executes like a normal function, which means all that code executes again. And that has one important implication. Of course, this function which you pass to the button is recreated. This is now a brand new function for every render or every execution cycle of the app function. because in the end it's just a normal constant which we recreate. All that code in here is executed again. So of course, a new function is created. This is not the same function all the time. It's a function that does the same thing. But technically, to JavaScript, it's a brand new function for every time the app function is being executed. That's, by the way, also true for false being passed to demo output. Previously, I said that this never changes. Even that technically was not correct. This app function is re-executed, therefore a new false value is created. So even if we had false in the last render cycle too, now we have a new false. But if that's the case, why does React Memo then work on the demo output but not on the button? What's the difference between false and the function here? If a new false is created and a new function is created, shouldn't then both components be re-evaluated? Well, for that you have to keep in mind that false is a boolean, and booleans like strings and numbers are primitive values in JavaScript. Now what React Memo does in the end is it has a look at all the prop values, and in the end it compares props show to props previous.show, you could say. This is not exactly what it does internally, but you can imagine it like that. So in the end, it has a look at the previous value for the show prop and compares it to the current value, and it does so with a regular comparison operator. Now for primitive values, that will work, because for primitive values, if I compare two booleans, I get true if they are the same. If I compare two strings, I get true if they are the same. Now technically, that is a different boolean than this here, and that's a different string than this. These are two different values. But for primitive values, this comparison works. Now that's not true if you compare arrays or objects or functions. For comparing two arrays, let's say, which look similar to us humans, in JavaScript, they are not equal. And that's not React specific, that is JavaScript. And attached to this lecture, you find an article and a video on primitive and reference values so that you really understand this, because that's a core concept of JavaScript. Now, it's important to understand that functions are just objects in JavaScript. Again, not React specific, that's just JavaScript. So here a new function object is created with every time the app function runs. And this function object is passed to the onClick prop. Now therefore, button in the end compares props onClick to props previous.onClick, for example. And in there we have two function objects. Now two objects, even if they have the same content, are never equal in JavaScript when compared like this. And therefore, React Memo finds out that the value changed just because of how JavaScript works. Now that is really important to understand. I know it's a common gotcha and something a lot of developers, even more experienced ones, are struggling with. That's why I'm emphasizing it like this. This is crucial to understand and to get right. Now, of course, as a result of that, does this mean that React Memo is useless for components that receive objects or arrays or functions through their props? No, thankfully not. Let's have a look at the solution in the next lecture. We can make React Memo work for prop values that are objects as well. We just need to tweak the way we create and store those objects a little bit. There is an extra hook provided by React that helps us with that, and that is the useCallback hook. useCallback is a hook that allows us to basically store a function across component executions. So it allows us to tell React that we want to save a function and that this function should not be recreated with every execution. With that, one and the same function object is stored, so one and the same place in memory, and therefore the comparison does work. Because, just to make this clear again as well, if you have object 1 like this, and you have object 2 like this, which look similar, you learned that they aren't similar in JavaScript. If you, however, set object 2 equal to object 1, you point at the exact same place in memory, and therefore now object 1 will be equal to object 2. And that's in the end what useCallback does for us. It will save a function of our choice, basically somewhere in React's internal storage, and will always reuse that same function object then when this component function executes. And using it is simple. We just wrap the function we want to save with it. So here we use the useCallback hook and pass our function as a first argument to useCallback. And useCallback then returns that stored function, and when the app function reruns, useCallback will look for that stored function, which React stores for us, and reuse that same function object. So if we know that this function should never change, we can use useCallback to store it. Now you see I got some yellow squiggly lines here though, which tells me that I did probably forget to pass an array of dependencies. useCallback, like useEffect, actually wants a second argument, and it wants it even more so than useEffect. And just like for useEffect, the second argument should be an array of dependencies of this useCallback call. And the dependencies here are the same as they are for useEffect. Anything you use in your function, which is coming from the surrounding component, so any state or props or context, should be specified here. Now here we only have the state updating function, and we could add this as a dependency, but we don't have to, because as mentioned earlier in the course, React guarantees us, actually with help of useCallback probably, that this will never change, so that this will always be the same function object. Hence, this is an exception which we don't have to add. And then in this simple callback, we have nothing else. Keep in mind that this code here is just a function we pass to setShowParagraph, so that is totally contained inside of our callback function. So therefore here we have an empty array of dependencies, which basically tells React that this callback function, this function here, which we want to store in ToggleParagraphHandler ultimately, will never change, that it has no dependencies, and that therefore always the same function object should be reused when the app component re-renders. Hence now if I save that and I reload, we see button running once, but then you never see it again. Because now React Memo is able to do its job because we ensure that all the prop values we pass in are comparable. In this case, because this ToggleParagraphHandler function object is guaranteed to always be the exact same object in memory because of useCallback. Let me come back to useCallback because it is important to understand this. useCallback allows you to save a function so that you can reuse it. Now you had to specify this strange dependency array, and I don't know about you, but initially you might think, what do I need this for? My function has always the same logic across re-render cycles. Well, keep in mind that in JavaScript, functions are closures, which means they close over the values that are available in their environment. Now again, if you're not 100% sure about closures, attached you find some resources that get you started with them, because you need to know closures to fully grasp how React works. Let me give you a concrete example. Let's say we have a second button, which enables the toggling functionality. So a button that makes the other button work. Allow toggling. For that, we need a new state. Allow toggle and set allow toggle. And initially that's false. And we have a new function here. Allow toggle handler. We could again use callback, but for the moment, let's omit it. Doesn't matter here. Here, I want to call set allow toggle and set it to true. So I always set it to true here. This does not toggle the toggle value, it just enables toggling for the other button. Because now, and that's the gotcha, I will not only bind the allow toggle handler here to the new button. Instead, I will use the allow toggle state snapshot in my other function here to check whether I'm allowed to set show paragraph. So now here I will check if allow toggle is true, and only if it is, set show paragraph will be called. So the show paragraph state will only be updated if toggling is allowed. And now I will also reuse show paragraph here to replace my hard-coded false value. With that, if the app reloads, you will see that if I click the toggle paragraph button, nothing happens. Now if I click allow toggling, now the other button should do something, and when we click it, we also should see app running. However, if I click it, still nothing happens. And that's because functions are closures in JavaScript and because we're not using useCallback correctly right now. We even got some yellow squiggly lines here to make us aware of that problem. At least I got them here. Now what is the problem though? Functions in JavaScript are closures. That means when a function is defined, which happens when the app function runs in this function's case, when that function here is defined, JavaScript basically locks in all the variables that we're using in there. All the variables that are defined outside of the function that we are using, I should say. In this case, the allow toggle variable. That is a variable or a constant coming from the app function, and I'm using it inside of this function. Therefore, JavaScript closes over that constant and basically stores that constant for that function definition. That means the next time this function here, the toggle paragraph handler, is executed, this stored variable will be used. And with that, the value of that variable at the point of time it was stored. This generally is perfect because this allows us to use variables from outside the function in the function and call that function at any point of time we want, which is exactly what we want for a function that we bind to a button. The problem with that and with useCallback, however, is that with useCallback, we're telling React to store that function and exactly that function somewhere in memory. Now, when the app function is re-evaluated and re-executed because the toggle state changed, then React will not recreate this function because we're using useCallback where we told React that we don't want to recreate it under all circumstances. So therefore, the allow toggle value React stored for our function is still the old allow toggle value from the first time the app component was executed, not the most recent one. Because JavaScript, as I just explained, stored allow toggle, this constant, when it created that function here. And that's of course a gotcha here, that's a problem. There are cases where we actually want to recreate a function because values being used in that function that are coming from outside the function might have changed. And here we have such a case. So here we would want to add allow toggle as a dependency in our dependency array. And that tells React that we generally want to store that function. But whenever allow toggle changes and it has a new value, we want to recreate that function and store that new recreated function. And this ensures that we always use the latest allow toggle value inside of that stored function. If allow toggle does not change, however, then we don't recreate the function. And with that, if I save this, if we go back, now if I click toggle paragraph, nothing happens initially. However, if I now click on allow toggling, now we'll see that if I now click toggle paragraph, we do get our paragraph and all the expected output. It's also worth noting, of course, that for toggle paragraph, we see button running, but we only see it once. And that's actually our second button where React Memo has no effect because we're not using useCallback on the allow toggle handler. We would see it twice if the button for toggle paragraph would also be re-rendered. But that's not the case because our useCallback call here ensures that we're not rebuilding this function every time. We only did that once when allow toggle changed. Now I know these are concepts that can be confusing. In the end, it's not so much React though. It's more JavaScript, and you have to understand how closures work, and you have to understand that primitive reference value concept. If both is clear, it's absolutely clear how React works. And I hope that this and the last lectures could help you understand that and made it clear how use callback works, how functions are re-executed, and how React Memo works, and how that works together with use callback. So now, before we proceed, let me sum up what we just learned, so that this is all really clear because it is important. In React apps, you work with components, typically with function components in modern React. Those components have one job in the end, and that is this JSX code which they return. This tells React what the output of that component should be. Now, in your React components, you can work with state, or with props, or with context, though props and context, as I mentioned, all come down to state changes in the end, to make changes to a component and to make changes to the data that affects this component or that affects parts of your application. Whenever you change state in a component, that component where the state changed is re-evaluated, and that simply means that the component function is executed again. So all this code runs again, and therefore we get a new output. This might actually be exactly the same output as before, but it could also look different. For example, if suddenly a paragraph is rendered or not, or as in the case of the demo output component, if the text is rendered or not. React simply takes the result of this latest evaluation and compares it to the previous evaluation's result. And it does that for all affected components. And then it hands off any changes, any differences it identified to, in our case, React DOM, because we are using React DOM to render our React app here in the index.js file. And React DOM will take those changes and apply them to the real DOM in the browser. And really only those changes, nothing else. Now, when React re-evaluates a component, it does not just re-evaluate that component, but since it reruns the entire function and therefore also rebuilds this JSX code, rebuilds the output for this latest snapshot, so to say, it will also rerun all components that you have in this JSX code. Like in this case, it will rerun the demo output and the button components. Now, to avoid unnecessary re-executions of child components, you can use React Memo to tell React, hey, please only execute this component function again if the props really changed. So if we got real new values in there. If we got no new values, please don't re-execute this function. Now, since re-evaluating a component means that the entire component function runs again, that can have strange effects if you're not aware of the fact that this really means that everything in this function runs again. And therefore, if you, for example, create functions in the function and you pass those functions through props to other components, you will indeed get a new function object, and even React Memo will then not be able to help you because objects are reference values and comparing them with equal signs, which is what React Memo does under the hood, will not work. For primitive values, you will therefore not have that problem. That's where use callback comes in and can help you, because with use callback you can tell React that it should store a function and not recreate it when the surrounding function runs again, as long as certain dependencies didn't change. That is what we learned thus far. Now, there are a couple of open questions though. For example, if the app function runs again whenever the state changes, doesn't this mean that we all the time reinitialize our state? Because we also execute use state over and over again then. Why is this not causing problems? Well, it's questions like this and general state-related questions that we're going to dive in next. Obviously, state is a crucial concept in React. Ultimately, everything comes down to state when it comes to re-rendering components and changing what's on the screen. So therefore, components and their interaction with state, that is really a core aspect of React. And it is worth noting that both, of course, is managed by React. This components concept comes from the React library, and React also takes care of your state that is attached to components. It takes care, for example, by using the useState hook, and that's how this interaction between components and state is handled. Speaking of that, one of the most common forms of managing state is to use the useState hook. With that, you create a new piece of state, you could say, and you automatically attach it to a component, the component in which you call useState. This attachment, is done behind the scenes by React. Because when you call useState, React behind the scenes creates a new state variable, you could say, which React manages for you, and which React also for you ties to this component. Now, I mentioned at the end of last lecture that it's strange that even though we call useState every time the app function runs again, we don't seem to lose or reinitialize our state all the time. The reason for that is simple. useState is coming from React, and I just said that React is managing the state and the connection to the component for you. And as part of that management process, React makes sure that useState and the value you pass as a default value to useState essentially is only considered once. The first time ever a component is rendered, so the very first time the app component runs, useState, when executed, creates a new state variable which is handed off to React and which is managed by React. React then basically memorizes to which component that belongs, the app component in our case, and it uses the default value to initialize the state with that value. For subsequent app function calls, so for re-evaluations of the app component, when useState is being called, no new state is being created. Instead, React recognizes that it already has a state for this component, and it instead simply updates that state as needed, because the app function re-ran because some state changed most likely, and therefore React will only do that state management and updating. It will never reinitialize the state unless the component was totally removed from the DOM in the meantime, which in case of the app component will never happen since it's our root component. For child components, if it's rendered conditionally, for example, a component might be removed, and in that case, if it's then later reattached, a new state would be initialized. But as long as a component stays attached to the DOM, state is only updated after that first initialization. That's one important note to take, and of course the same is true for useReducer, for example. Now that's not all you need to know about state though. We know how React manages state, or at least we have an idea, but there's one thing which is important, which I mentioned before, but which I now want to emphasize again, and that is how React handles state updates. In your code, you might have a component, and in that component you might manage some state with help of the useState hook, and therefore React in the end manages that state for you. Let's say the initial state for this product component is DVD. So we have a DVD as a product here. Now eventually, because a user clicked a button or whatever, in that component we update that state. For example, with setNewProduct, that could be our state updating function returned by the useState hook, and we set the new product to book. So from DVD to book. Now what happens with that is not that DVD is instantly, after setNewProduct finishes execution, is replaced. DVD is not instantly replaced just because setNewProduct is done running. Instead, calling setNewProduct and calling those state updating functions in general schedules a state update with the data book. But that's now a scheduled state change. React is aware of it, React plans on processing it, React doesn't process it immediately though. Now, in reality, most of the time, state changes, scheduled state changes, will be processed very fast, pretty much instantly. So in reality, it might feel instant. If we click a button and that removes a paragraph, to us as a human, that happens instantly. But React reserves the right of actually postponing that state change. For example, because a lot of other performance-intensive tasks are going on at the same moment, potentially tasks that React considers to have a higher priority. Let's say on your screen you have an input field where the user is able to type something. Reacting to that user input would have a higher priority than changing some text on the screen. And for reasons like that, React might postpone scheduled state changes. Now, what React does is it guarantees you that the order of state changes for one and the same type of state is guaranteed. So if we call setNewProduct again and we set this to, let's say, carpet or whatever, then this state change would not be performed before the previous state change. So the order is kept, but it's not necessarily executed immediately. Eventually, of course, it will be processed and your new state will be booked. And once that new state is active, once that state change was processed, React will reevaluate the component, it will rerun the component function. Now, because of that scheduling, where of course you might have multiple outstanding scheduled state changes at the same time, because of that, because multiple updates can be scheduled at the same time, because of that, it is recommended that you use this function form for updating your state if you depend on the previous state snapshot. In a lot of cases, this will probably not matter because it's processed so quickly that you can't even click fast enough to see a delay. But because it theoretically could be postponed, this is the safe way of ensuring that state changes are processed in order. And for every state change where you depend on the previous state, you get the latest state. Otherwise, you might just get the latest state when the component function was executed last, which is not necessarily the same state as if the state changes are executed in order. Because if you have multiple outstanding state changes, they all come from the same last re-render cycle of that app component. They all come from that last component snapshot. But of course, if they were processed, the component would re-render in between. But since they're all already scheduled, all outstanding states changes don't take that new in-between component result into account. That's why this function form is helpful, because there, React will actually ensure that for every outstanding state change, it looks into the latest state and gives you that, and does not use the latest state from the last time the component was re-rendered. That's an important difference between when the component was re-rendered and when a state change was scheduled. You can have multiple outstanding state changes from one and the same component re-evaluation. That's the key takeaway here, and that's why this matters. That's also why in the last non-project module, where we initially learned about useEffect and so on, it was safe to actually update our form validity based on the email and password is valid states inside of useEffect. Because just like using the function form for updating a state based on a previous state snapshot, useEffect actually, because of its dependency mechanism, is ensured to rerun the effect here every time a state or a value, which is a dependency, changed. And therefore, you can't miss outstanding state changes, because here it will simply rerun this effect for every time the component was re-executed, the component function was re-executed. It will thereafter always rerun the effect, and therefore you are also guaranteed to get the latest state when doing it like this. So these are simply two different patterns for dealing with one and the same problem, you could say, depending on what you're trying to achieve. Here we want a state update that depends on some other states. In this case, on the other hand, we want a state update that depends on the same state, just a previous snapshot of that state. So that state update scheduling is a mechanism you have to keep in mind. Not because you actively need to do something about that. React manages those scheduled updates for you, but because you need to write your code accordingly to rule out any danger of potentially working with outdated data. You rule it out when using that, you rule it out when working with useEffect. Now, there is another important thing you need to know about state in React. There, we actually have this nav context, and in the navigate handler, I do something which you see a couple of times throughout this course. I call two state updating functions after each other. Now, we just learned that just because you call such a function does not mean that in the very next line the state was updated. State was not updated here. Instead, we just learned that the update will be scheduled and eventually the entire component will rerun, so this component in this case, and then once this component reran, then we have the latest state available, not earlier. Now that's what we learned. Now here, however, we have two state updating functions after each other. That clearly means that two state updates will be scheduled. Does this, however, also mean that the component will be re-executed, re-evaluated twice? You could imagine that this happens, but that's actually not what React does here. Instead, if you have two state updates in the same synchronous code snippet after each other, so not in a promise in different then blocks, but in the same function, for example, where nothing in between would cause a time delay or anything like that. So if you have two synchronous lines of code after each other, where you then call a state updating function, in such cases, React will batch those state updates together. In one long synchronous process, so for example in one function that executes start to end without any callbacks or promises in between, in such cases React will take all the state updates that are produced by that function and it will batch them together into one state update. So back in this picture, even if we would not just update the new product here, but if we would update something totally different in the same function, we would still just have one scheduled state change, which then, however, just changes two different states. But it's one process. It's not two scheduled changes with two upcoming component re-executions, re-evaluations, but instead it's one scheduled change where all the different states you might want to affect are simply batched together. So state batching is another important concept you have to be aware of when working with React. So we learned about use callback. Attached you find a new mini example where I also want to dive into another hook that helps us with another optimization we could add. Here we have use callback to basically store a function to not recreate it. This is a function which I pass to the button through the onClick prop. The button internally uses React Memo, and because we store that function with use callback, the button will never re-render in this case, because its props never change, and React is aware of that. Now I'm also rendering a list here, and the interesting thing is that the list is sorted. It's sorted in an ascending way. Now, the data which I put into the list is not sorted, it's in random order, as you can tell here. So that means that, of course, obviously in the list we're doing some sorting. And indeed, here I'm sorting my list with this simple built-in sort method, to which I just pass a function that defines how the sorting should happen. You can look up the sort method documentation if you want to learn more about that. And that gives me my sorted list, which I then output. Now, the thing is, sometimes in your code, sometimes in your components, you might have logic like this, which could be a bit more performance intensive. Obviously, that's a short list, sorting will be quick, but for longer lists or simply for other tasks, you might have some code which takes quite some time. Eventually, this code of course needs to execute, but you certainly don't want to run this code every time the entire component is re-evaluated. Now, of course, we learned what we can do to avoid unnecessary re-evaluations. We can use React Memo here, right? With that, we can wrap the demo list. And with this shouldn't run unnecessarily. If I now console log demo list running here, we see that, of course, it runs initially. That means the list was sorted, but thereafter it shouldn't run again. Well, actually, I have this button. When I click it, I change the title here, and the title is part of my list here. Therefore, when I click the button, demo list runs again, and it needs to run again because one of its props changed. The title changed. It has a real different value there. So React Memo is not failing. It needs to rerun in this case. Now, as a side note, of course, currently it would always rerun when the parent component re-renders though, because at least this array here is constantly recreated in the parent component whenever the parent component runs. So even if the title would not change, if the parent component would rerun for some other reason, the demo list component would be re-executed because we always generate a new array. Like functions, arrays are objects are reference values, and therefore two arrays, even if they have the exact same elements in the same order, are never the same, because they occupy two different places in memory. But here we don't even have that problem, but instead, as I just explained, because the title changes, we have a valid reason to rebuild demo list. So sometimes the component reruns is re-evaluated, and still you might not want to repeat every bit of work you did there in the past, especially if the work you would have to redo is more performance intensive. And sorting is one of the more performance intensive tasks you can do in your components. So, is there a solution to that? Yes, there is. We have use callback to store function objects and only rebuild them when some input changed. We have something similar for all other kinds of data. And that is another hook which we can import, the useMemo hook. useMemo basically allows you to memoize, so basically that means to store any kind of data which you want to store, just like useCallback does it for functions. And here we could memoize, and yes, that's memoize, not memorize. These are two different terms, but it's pretty much the same here in this context. So you can memoize the result of this sorting here, simply by calling useMemo here, and now useMemo as a first argument wants a function. That is, however, not a function that will be memorized. Instead, that function should return what you want to store. So in this case, it should return that sorted array. Now, just like useCallback, useMemo wants a second argument, which is an array of dependencies. Basically, to ensure that this stored value is updated whenever one of the values you're using in there changes. And in this case, indeed, whenever items changes, whenever we get new items, we want to resort them. So items are a dependency here. We could add props here, because items are pulled out of props, but that means that the entire props object is our dependency, and therefore this would essentially always recalculate. So a more elegant way is something we used on useEffect and its dependencies earlier in the course. We can use destructuring to pull something out of props, in this case, to pull the items out of props. And then we can just add the items here as a dependency and use just items here for sorting. And now this will only rebuild this if items changed. Now let's see when that happens. For that I can add a console log here, items sorted. Let's see how often this runs. If I reload, we see it runs initially, of course, but it still also runs when I change the title. Now the idea was that it shouldn't run there. Why is it running again then? Well, because items indeed changed. That's what I mentioned earlier, a few minutes ago. The items here actually are always recreated when app reruns, because we always create a new array here. So even if it's technically a similar array with the same values in the same order, it's still technically a new array in memory, and that is treated as a brand new object which isn't the same as the old array, even if it contains the same values. That's this reference value thing I mentioned a couple of times throughout this module already. So to ensure that we don't unnecessarily pass a new array here, we can of course also use memo here. We simply import useMemo, and then here we can wrap it, add this function which should return this array, and add our dependencies, which here is an empty array. We got an empty dependencies array here, because here this of course never changes. It has no external dependencies. It's all hard-coded in here. So therefore now we also call useMemo here, and of course we can also pull that out of there and say list items is the result of calling useMemo, and then we pass list items here to items. And with that now, we should not unnecessarily sort the list again. Now we see items sorted initially, but if I click change list title, we don't see it again because of useMemo. Now, I will say you will use useMemo far less often than you use useCallback, because memorizing functions is much more useful, and you need that more often than memorizing data. You essentially want to memorize data if it would be performance intensive to recalculate something based on it. Otherwise, it might not really be worth it, because you always have to keep in mind that if you store data with useMemo, of course that occupies some memory, and of course this storing functionality also takes up some performance. So this is not something you want to use on every value you're using. If you got a scenario like this one here though, where you want to sort something, then it might be worth a look, because then using useMemo and avoiding unnecessary sorting steps in future component updates, that might be very well worth it. Now, throughout this course, of course, we'll see more examples, and therefore throughout this course alone, you will get a better feeling for when you want to use what. In this module, I just want to put all those things out there and explain them so that you understand them and so that you are aware of them. When you use them, always comes with experience, depends on your preferences, your exact use case, and there also isn't a clear right or wrong. It's just something you should be aware of so that you can look into optimizations like this if you find out that your application is slow or that you want to improve some parts of your application.